Hey, what is up everyone? My name is Sagar and we are back here with another video. And this is the lecture 4 of our Java and DSA course. And in this particular video, we will be learning about operators. So, without making any further ado, let's get started. So, first of all, I will create my new Java class, lecture 4, and press enter. Generate main method. Okay, now our question is, what are operators? What if I say you already know the answer? What if I say you are already using them? What if I say, okay, that's enough, but this is true that we are already using them. These plus, minus, multiply, divide, all these are operators, and we learnt all this in our childhood in mathematics. But now the question is why and how we are using them in programming. See, these are the symbols with some particular meaning. Like in mathematics, we have this plus operator. This is used to add two values. Suppose I have 2 and 3, then I will write it as 2 plus 3, and it will give me my result, that is 5. Same as in programming, we already know that things are stored in the form of bits, 0 1 binary, and we can perform these operators with the help of gates. What are gates? Gates are something like electrical circuits that we use to perform operations in our data. Don't enter in these things, that's not a part of our DSA course. So operators are just symbols with some particular meaning. They can be of one or more characters, and same as in mathematics, we use them to perform some specific task. There is one question, can we create our custom operators in Java? The answer is no, Java won't allow that. And if you want to know about the reason, I will share a link of some geeky documentation in the description. So Java have mainly 5 type of operators, and these are arithmetic, assignment, relational, no, that's comparison, or we can say both, and bitwise and logical. So that is all we are going to learn today. And now let's get started with our first one, and that is arithmetic. So there are basically 5 arithmetic operators in Java, and let me write them all. Arithmetic, oh, this is correct, plus, minus, this is multiply, and this is divide, and this is modulo. Yeah, and now let's see some use cases. Suppose I have one integer as 1 and another as 5. I can use any of these arithmetic operators to perform some required action on my integer values. Suppose I want to add them, so I will write it as a plus b. But there is an error, introduce local variable, we don't know what is that. So this error is because these arithmetic operators return some value, and that value is the same thing, or we can say same type of the values we are using them with. That means if I am using this plus operator on integer values, it will return me an integer. So I will write it as this, it's c equals to a plus b. We are already familiar with these things, so let me just move ahead. And here d equals to a minus b, and e equals to a into b. In after e there is f, a slash b, that slash is divide operator, and after f we have a b c d e f g equals to a modulo b, and that operator is called as modulo. That means it returns the remainder when I divide this a with this b. Suppose I have some different example. There is 5 and b is 2, and I will print this g, and the answer is 1. Why? Because when we divide this 5 with 2, the remainder is 1. Simple mathematics. And when I try to print this f, it will return me the base value after dividing these two. That means 5 divided by 2, that is 2. So the answer will be 2. Yes. So now let's move ahead to assignment operators. And assignment operator are of two types, simple and compound. First I will write assignment, that's correct. First I will write simple, That's it. This is the only simple assignment operator, and we are already using it. Here you can see int a equals to 5, int b equals to 2, and int c equals to a plus b. That means here this assignment operator is used to assign that 2 value to my b variable. And after that we have compound assignment operators. Compound, we will be doing it at last, because first we have to learn about others, and the next ones are relational or comparison operators. So relational or comparison, and there are mainly 6 comparison operators. First less than, then greater than, less than equals to, greater than equals to, double equals to, and not equals to. 1 2 3 4 5 6. Yeah, I think their purpose is clear with their name. They are comparison operators. They are used to compare 2 or more values, and the first one is less than. So let us see some example. So before starting, let me tell you that these comparison operators return boolean values. Unlike arithmetic, arithmetic are basically used for number values and work on them, but here relational or comparison operators are used with conditions. We will be learning about conditions in our upcoming video, but today let me show you some example. Here I am saying that they return boolean values, so I have to create my boolean variable. Boolean bool equals to, and then I have to use this less than operator. So I will write it as 5 less than 8. That is always true. 5 is less than 8 and it will return me true. So I will print my bool. As you can see here, true. And let's say I am using some different operator. This greater than, 5 is greater than 8. No, that's not true. So our output will be false. And that is, so after that we have to use this less than equal to, less than equal to, and that is also true. Why? Because this less than equals to operator means that either this value is less than or equals to another value. So if I write it as 5, that this means it is also true, because 5 is not less than but it is equal to 5. So it will return me true. And after that we have this double equals to, that means it will return true only if both values are equal, and 5 and 5 are equal, so it will return me true. And after that we have not equals to, that means 5 is not equal to 5, that is false. So let me run this, and that is false. And if I say 6 is not equal to 5, that is true. So our bool variable will be true. Let me run this, and it is true. And after that we have bitwise operators. I love them. Seriously, they are on steroids. And suppose in arithmetic operators I have this plus and I have to add these values 5 and 2, then I will write it as 5 plus 2, and in binary form 5 is 101 and 2 is 010. So after adding them 111, that will be 7. But here bitwise operators directly work on bits. Obviously that means they are faster and efficient. And here we have mainly 3 operators. First this ampersand, that is bitwise and after that we have this bitwise OR. You can see here it is with that backslash, and after that we have XOR. Don't worry, our lecture 5 is all about bits and we will be doing them there. So after bitwise we have logical operators. Logical, and there we have mainly 2 operators, double and double OR. Now this is a logical and this is a logical OR operator. But wait, they are also in bitwise, but they are not same. These logical operators return boolean values, same as in relational operators, as you can see here. And these bitwise operator return different values according to their uses, as in arithmetic operator you can see there. Normally these logical operators are also used with conditions, but here let us see some example as they return some boolean value. So I will write it as this, and if I write it as 5 is less than 6, and that is logical and 6 is less than 7. So here we know that 5 is less than 6, that is true, and 6 is also less than 7, so this is true and this is also true. That means this logical AND operator will only return true only if both conditions are true. That means here 5 is less than 6, that is true, and here 6 is less than 7, that is also true. So our whole result will be true, and here bool is true, so I will print it out, bool. Let's run this, and bool will be there. Here you can see true because both conditions are true. And let us say if I am writing here 1, here 5 is less than 6, that is true, and 6 is less than 1, that is not true. Here 1 out of 2 conditions are false, that means the whole result will be false. Okay, let's run this, and it is false there. So after this we can have a conclusion that in AND operator, if first one is true and second one is also true, then our result will be true. And if first one is false and second one is true, then our result will be false. And if first one is true and second one is false, that means our result will be false. And if both are false, then it is false. But here when we are talking about logical OR operator, things are totally reversed. That means first logical OR, if first condition is true or the second condition is true, that means true or true, result will be true. And if first condition is true or second is false, that means our result will be true. And if first condition is false or second is true, that means the outcome will be true. And last, first condition is false or second is false, that means the outcome will be false. So here you can see this OR operator is biased for true, and that means even if there is only one true value, the whole outcome will be true. And I can write it as a boolean bool 5 is less than 6, that is true, or I can write it as 4 is greater than 9, that is not true. Or I can also write multiple conditions, and 6 is less than 1, that is also not true. So when I print it out, our outcome should be true, as you can see here, because here we are using logical OR operator which is biased for true values. But when we are using AND values, that means logical AND, here one condition is false, that means whole outcome will be false. As you can see here, the outcome is false, and we can also write it as this. So here the flow will be like this: 5 is less than 6, that is true, and 4 is greater than 9, that is not true, so this is false. And after that, or 6 is less than 1, that is also false. So false or false, false or false, false or false, as you can see here, that will be false, so our outcome will be false, as you can see here. But when I write it as this, here logical AND and here logical OR, so the answer will be true. So here 5 is less than 6, that is true, or 4 is greater than 9, that is false. But here we have logical OR operator that is biased for true values, so when we have one true value, then we don't need to check further values, because if we are using logical OR operator, then the final result will be true. as you can see here, true. You can add more and more values and play with these logical operators. So after this, let's talk about compound assignment operators. There we go. Compound assignment operators are like this: plus equals to, minus equals to, multiply equals to, or we can say divide equals to, or so on. So these are compound operators. Compound means we are using two or more operators together to perform some task. As you can see here, plus equals to, plus is a arithmetic operator and equals to is a assignment operator. So now let us see some example. Suppose I have num equals to 10. So suppose I have to add 5 to my number, so I can write it as num plus 5, but I have to store it somewhere, so I will store it back to my number. Num equals to num plus 5, and now my number will be 15. So let me print it out. Num, as you can see here, 15. But here you can see I am writing this num variable two times, and here I am also using two operators. So I will make a compound operator and write it as this: num plus equals to 5, and the output will be exact same. As you can see here, 15. So that compound operator means add 5 to my num value. Here num is 10, so after adding 5 it will be 15, and store it back to num. That means our num will be now 15. So after venting, you can see here 15. So there are multiple compound operators like modulo equals to, and equals to. Here and is a bitwise operator. Or equals to, XOR equals to. We also have some shift operators, and we will be doing them in our next video. There is this left shift, right shift, and so on. There are also some other operators like unary or ternary, but we will be doing them on the go. And now it is time for our practice problem. So today you got one easy task. First take one input, and so first of all you have to take one integer and boolean input. In our previous video we learned how to take user input, and here you have to do it with scanner class, and here you have to do it with scanner class. So first one is integer input, and that will be someone's age, and the second one is boolean, and that boolean will represent whether someone wants to vote or not. And the task is to print the boolean result using logical and relational operator. So you have to print some boolean result, and the result will be true if age is 18 or above. Okay, you have to compare some values, and also when that person agrees to vote. Okay, we will do this, and the result will be false if age is less than 18, or that person not agrees to vote. Till now we don't have any answers from the previous lectures. Isn't there anyone who wants free shout out? Do share your answer in the comment section. So that is it for today, everyone. Hope you like this video. Subscribe to our channel, please, and share your answer in the comment section, and I will see you in the next one.